The next gate in this series is the XOR gate. Again, this is a combination of three gates: the OR gate, the NAND gate, and the AND gate. As we have pointed out, that calculating the outcome of multiple gates can prove to be tricky. So here we have included the outcomes from each stage. With an input of 0 and 0, the output of an XOR gate is 0. If we look at our multigate, the input to the NAND gate is 0 and 0. This means it has an output of 1. The OR gate also has an input of 0 and 0, which means an output of 0. So the input to the AND gate is 0 and 1, which then results in an output of 0. Now when the input to the XOR gate is 1 and 0, the output is 1. If we look at our multigate, the input to the NAND gate is 1 and 0, which means an output of 1. Whilst the input to the OR gate is also 1 and 0, that results in a 1. Therefore, the input to the AND gate is 1 and 1, which means the output is 1. Now to change the input to 0 and 1, the XOR gate results in a 1. The input to the NAND gate in our multigate is 0 and 1, which means the output from this gate is 1. The input to our NOT gate is also 0 and 1, which means an output of 1. The input to the AND gate is 1 and 1, that results in an output of 1. Finally, an input of 1 and 1 is applied to the XOR gate, which results in an output of 0. With an input of 1 and 1 applied to the NAND gate results in an output of 0. The input to the OR gate is 1 and 1, which means an output of 1. The input to the AND gate is 1 and 0, which results in an output of 0. This is a schematical diagram of an XOR gate. As we can see that although we are still using just simple components such as transistors, resistors, a couple of switches and an LED, the configuration has now become very complicated. Bear in mind, in this example we are talking about one single gate, and in practice we could be dealing with thousands. And here is a practical circuit. When both switches are in the off state, the LED remains off. So when the input is 0 and 0, the output is 0. When SW1 is switched on and SW2 remains off, current flows through the LED and turns it on. So when the input is 1 and 0, the output is 1. When SW2 is turned on and SW1 is off, current flows through the LED and again turns it on. Therefore, when the input is 0 and 1, the output is 1. Finally, when both switches are on, the LED does not light. So when the input is 1 and 1, the output is 0.